All right, so we're going to talk about domain and range, but before I tell you about domain and range, I want to teach you something called interval notation. Yes. Switching gears to notes here. All right, so we use interval notation when we want to describe an interval of numbers, okay? A set of numbers, what they span. So, for instance, you may be familiar with something like x is greater than 5, right? That's a set of numbers. Do we all agree? Yep. And you probably know how to describe it that way. I imagine you also, absolutely, Ozzy, know how to describe it on a graph where you put the 5 there and then you have to put a special kind of dot. Do you remember that?
Circle.
An open circle. Why?
Because if it's a full circle, it means it's equal. It keeps going on.
That's right. So if it's closed in, that means it includes 5. But if it's open, that means it does not include 5, right?
So interval and notation will work in different ways.
It's going to describe the same thing, but it's going to be a different way to describe it. A little more sophisticated way, more accepted way. Say that again.
You want us to write them different from each other?
Well, from now on, I want you to use only interval notation. So I'm going to show you how to do it. Okay. So the difference, and I'm going to show you here the or equal to so we can compare the two. And we said if it's or equal to, that means it includes that number and we shade that bubble in, right? And then we draw an arrow indicating which way it goes. So I'm greater than, so the numbers get bigger to the right, so I'm headed off in this direction, yes? Okay. That's easy. All right, a couple of things I want you to think about before I show you the actual notation. The first thing is, as I move further and further to the right, what am I getting closer to? The further I go right, what am I getting closer to?
Bigger number.
Bigger number. What's a mathematical way to say big as you can think?
Infinity.
Infinity. Good job. I'm going to say if I go forever to the right, I'm talking about positive infinity. Does everybody know the infinity sign? It's like a sideways 8. So this way, I'm going to say is negative infinity. Yes.
The marching band shows are based on numbers.
Yeah.
Say that one more time.
The marching band show today is called numbers, and it's based on numbers.
Yeah.
Really? That is so
We have
cool.
pi, the golden ratio, and the infinity.
Hey, that's awesome. That shows what you're marching to, like your whole...
Those are all of our.
Those are the songs. We form like an infinity sign at one point, and then it goes around.
Nice. Nice. I like it. All right. Infinity, negative infinity. So would you agree in words that this first inequality is saying that it goes from 5 to infinity but not including 5? Yes? Well, I'm going to change some symbols up on you a little bit. Instead of a bubble or a circle, I am going to use a parenthesis that opens this way.
Oh, what was that?
I don't know, it glitched or something. There it goes. Okay.
Okay, so you want us to draw a parenthesis.
All right. And I am going to say if it's including that number, I'm going to make that a bracket. And I am going to tell you to, instead of drawing a picture, let's put this in numbers and let's give it a range. Okay? So and we always go smallest to biggest when we're talking about range. So if I want the range of this first inequality, I start with what? 5. I'm going to use then a comma that tells me I want to go up to, well, what's the biggest it can be from there?
Infinity.
Infinity. I'm going to use a parenthesis here because that tells me don't include 5. And obviously I can't include infinity because that's kind of conceptual, right? So I'm going to put a parenthesis there. So this is the interval notation of that inequality. Pretty easy?
Puts brackets around them.
If it's inclusive, okay?
So if it's including it.
Right. I would do a bracket. It starts at 5 and it goes to infinity. Infinities always get parentheses, again, because that's kind of a conceptual idea. Y'all follow me? Yes.
What does the brackets mean again?
The brackets mean includes. So if you have greater than or equal to or less than or equal to, you're going to use a bracket. Okay? Let's try a couple. Need me to wait a second? Oh, somebody said something. Okay. Let's say I want you to write an interval notation that x is less than -2. An interval notation. Remember, interval notation goes from smallest to biggest. So think about it before you answer. What should I start with here? Close. Think about a number line, absolutely. Think about a number line and which way your arrow's going and what's happening. So yes, you would start with -infinity, right? It's going off forever to the left. If I were to put it on a number line, -2. Comma, what does it go up to? -2. Do I need a bracket or a parenthesis? Why? It's not included. Exactly. It doesn't include 2. Does that make sense to you?
Why does it not include 2? That's my question.
Okay, because there's no line under this.
Yes. Okay, sorry.
Okay, you with me?
Yep.
All right. Let's make it a little bit harder. Do what? That's X. This is, do you remember the compound inequalities that you learned? Ands and ors. This is an and. So if you think about this on a number line, it will help you write it in interval notation, okay? And once you get the hang of it, you won't have to do that anymore. Well, if you think about your number line, if you've got 2 here and a 5 here, this is telling you that you want everything sandwiched in between, right?
So X is going to be somewhere.
But I need to think about my open and closed dots. The one on the 2 gets what? A solid or a closed, and the one on the 5,
You have to open.
absolutely. So remember what corresponds to what with brackets and parentheses. Tell me what I start with. Bracket. Okay. 2, comma 5, then a parenthesis. Good job. Does that make sense to everybody?
Why don't we put the infinity in that one?
Because it doesn't go to infinity. It just goes, now if my arrow had been drawn this way, then yes, it would go to infinity. But with a compound inequality like this, it says just include the middle stuff. How about, do y'all remember learning ors?
Oh, yes.
Ors literally have the word or written in them.
Not just a picture of an or from a road.
Yes, yes, you are correct. So when we graph ors, they look, I used to, when I taught Algebra 1, I used to teach them they look like a chicken wing because I would draw them up off the graph. So if you think about this on a number line, this is saying that x can be less than or equal to 0, which goes off this direction, or greater than 5. The first one is what kind of circle, open or closed? Closed.
Yeah, cold.
What's the next one? Open. So, do you see that this has two pieces to it? So there's a way we can join things in interval notation. And you may remember learning, do you remember learning union and intersection when you were talking about sets of numbers? It would have been like elementary school probably, no? All right, well, union lets us join two different pieces. So what we're going to do when we look at this, let's write this side first. If you write in interval notation and describe that portion of the inequality, what would it be? Parenthesis. Yes. Then a bracket. Now, here's what, yes, negative infinity. Here's what's going to happen. All you have to do to join them is put a U. That is the mathematical symbol for union and tells us to join those two sets together, that together those two pieces make the whole set, okay? And now I need to pick back up with what? The other one. So what does that start with? 5. Parenthesis, you're right. 5, comma, infinity. Parenthesis always on the infinity.
So when it is like included, we only put the spots on the last one?
Yes, the only ones that get the bracket are the included ones. Does that make sense to everybody? Think you can do that? All right. So let's talk about domain and range. Because we're going to write our domain and range in interval notation. How many of you have heard of domain or range before? A few of you?
It's like the area. It's like an area.
Kind of. It describes what the variables what values they can take on. Okay? So, domain describes the x values or the input, whereas range describes the y values or the output of the function. So we're basically describing, we're telling everyone what can x be, what values can it take on when I have a certain equation, or what values can the y's take on, okay? Now we'll talk more in depth about domain and how algebraically some restrictions that happen to keep things from, keep it where you can't put certain numbers in. But that's really how I want you to think about domain right now, is when you look at the equation, for instance, if we look at the one we did on warm-ups, is there any number that you cannot put in for x? Can you put any number you want in for x?
Yes.
Sure you can. Okay? Correct. So, and if you think about it, things that would keep you from putting anything in would be if I had like x in the denominator. Because you can never have what in the denominator of a fraction? 0. So x couldn't be 0. If I had a radical, what can you never put under a radical? Negative, right? So if I had the square root of x, then there would be things that I couldn't put in for x. Do you see where I'm going with that? But in the case of my parabola, is there anything that I cannot put in for x? No, I can put anything I want and get a value back out, right? And if you look at the graph, whenever we graphed it, it's going to shape like that, right? So if you can put anything in, if it's open to any value of x, then we say that the domain is unrestricted, which is anything in the world in the real number system, which is negative infinity to infinity. Does that make sense to you? Yeah. An unrestricted domain, you can put anything in for x that you want to, is negative infinity to infinity. That describes all the values of x on the graph, because this goes on forever, and we know that it's inching out as it goes, and domain is left to right. Okay, that's x's. And we'll look at it graphically again in just a minute a little bit better. Yes? All right. Before I talk about range, let me actually put a graph here. Y'all like the yellow?
I love it.
Thank you. I like it too. All right, so I just talked to you kind of algebraically about domain, but I want you to see it graphically also. Okay, let's curve. If I'm looking at the x values and all you're looking at is this picture, we know that this is the x-axis and this is the y, right? So if I'm talking about domain and all I have is this picture to look at, do you see that the two ends of the graphs are kind of creeping out as they go up? You see that? So if I want to describe all the x values, now remember x is this axis here, so I'm looking left to right for domain, okay? It's what? Well, no, I want to know everything that x can be looking at this graph. Can you tell what the domain is looking? It can be, you're right, it can be all of those. It can be 3 or 4. What else can it be?
-3.
-3 and -4. What else can it be? Say it again, what'd you say? Unrestricted, absolutely. Look left to right. Do you ever get to a point on this graph where if you went to that x value, there's not a piece of graph somewhere up or down with it?
Wait, what are we looking at?
You're looking at the graph left to right, okay? And you're thinking, is there any time when I wouldn't get to that value, when I wouldn't have that value? And even though it may be really, really, really high, like if I come over here, well, there's still going to be a piece of graph that corresponds to that x value. It's going to be way up high, but it's going to eventually be there. That tells me that my domain is -infinity to infinity. Does that make sense? Okay.
Because it can be whatever it wants to be.
Exactly. Range is a little bit different, and we're going to really look at this graphically, and you got to kind of think about it, okay? If domain is left to right, what do you think range is? Range describes y. Up and down, okay? Now remember, we're going to start with smallest to biggest. Look at the graph. What is the smallest y value that the graph ever takes on? 0. Does everybody see that? The very smallest happens right here because this is my y-axis. Does it include 0? Yes, it's sitting right on 0. That tells me I need a bracket.
Wait, so what are we trying to figure out?
The range, all the values of y that the graph has. Absolutely. It goes up forever, so it's infinity. We're trying to describe all the values of y that this graph can possibly have. Okay? And y, my y-axis is my vertical axis. So I'm going to start with the smallest value that it ever has of y, which happens right here. And then I take it up to the biggest value. Well, the biggest value is infinity because it goes up forever and ever and ever.
So why doesn't the domain have 0 in it?
Well, because the domain is left to right instead of up and down. So if you look, there's nothing keeping it from moving further left and right. You see what I'm saying?
I got it.
Now, if it looked... If it looked like that, now my domain is restricted but not my range. Because left to right, it starts out -infinity, goes, but it stops right here. It can't go any further right. Do you see what I'm saying with that? So you see how the domain and range is different? Does everybody understand that?
Because the domain is left to right and the range is up and down.
Correct. That is correct. So what should your domain be on all of your quadratics that we're doing right now? -infinity to infinity. Your range is what's going to start changing.
Wait, but why isn't the y -infinity to infinity? Like, why is the lowest one 0?
Because if you're looking up and down, there is no graph. Whenever y goes negative, there's no graph down there.
As far as the
Oh,
blood work.
yeah.
Up and down, looking up and down.
That's an awful.
Correct.
Is this gonna have?
Let's do another one.
Is this gonna be how it's gonna be for the entire?
Every graph we do, we will describe the domain and range of from here on out. That's a big, big part of pre-cal and calculus too when you get there. Domain and range is always important. Yeah. Huh? I know. Let me do another one.
More graphs. I actually love working with that one.
All right, look at the green graph here. What's the domain? Absolutely.
Same thing.
If it's a standard parabola, a quadratic the way we're doing, it's negative infinity. So I would come over here, domain is negative infinity to infinity.
Because it's left to right.
Correct.
And they do that as far as.
Yep.
Oh, eventually.
Light bulb. How about the range? The range remembers my up and down. Absolutely. Negative infinity to
4.
bracket or parenthesis?
Bracket.
Bracket. What very special point is restricting my domain every time?
The vertex.
The vertex.
Why cook 4 consecutive?
You have to go smallest to biggest. So you start down on the graph and then you look up. Other questions? Let's see if you really understand domain and range. This is fun. Isn't this fun?
I love it.
I do too. I just love math.
It's not fun, but it ain't boring.
Well, I'm glad you're not bored.
What is that?
Terrible picture, but you get the point.
So it's double cross.
Is it rectangle?
It's a
Double
circle.
cross over them.
Well, it's actually not a circle, it's an ellipse, but
It's a football.
okay. An oval, there you go. We'll get to those. It's not a parabola, but I want to see if you understand domain and range
Okay.
graphically.
They'll both cancel each other out.
They don't cancel out.
They just go over each other?
Look at the, all right, think domain. All right, domain is which way? Left or right? Do you have it? What's the
The
domain?
domain is -2, 4, and the range is -2, 2.
Absolutely. Good job.
All the points are in the circle.
All right, the smallest value that x can take on, which is left to right, happens
Today,
here, right?
here and there.
Between here and here is where all of my x's occur, right? So that is -2 to 4. But there are actually points there, so I need brackets. My range,
Cynthia, what
like a
damn
box.
we need brackets?
is from -2 to 2. Brackets is whenever, brackets happen whenever the point is actually there. There's a point on the restricted part. All right, so -2 to 2, again, brackets. When we get to asymptotes and things that bound a graph, but they never actually touch what's bounding them, that's when we'll start to get into some parentheses and things with the domain and range. What do you think about domain and range? Does it make sense?
I don't know.
Okay. Let me stop this.